Hello everyone, welcome to this video on money language of condition monitoring. Oftentimes it is seen that we are very good in terms of technical aspects, whether making highly technical reports or explaining the technical terms to our customers or superiors. We are really very good at that. But still, we know that there are peoples at different levels who are not aware of such languages. So we should use a common language. The idea here is all the people, right from layman to CEO in your organization, should understand your report or your proposal in a better way, which needs a common language. Well, you know what is the common language of the world? Of course, it is the money language. So this video will be more focused about condition monitoring techniques, but still it can be used for other programs as well. I'm going to share some interesting case studies in this video. How do we speak from condition monitoring language to money language? Let's get started. So here comes a brief about me. I'm R. Shaktivel. I'm a condition monitoring professional holding a degree in mechanical engineering. I'm a certified chartered engineer from Institute of Engineers, and I'm an ISO category 3 vibration analyst and level 2 certified infrared thermographer, and I'm ASNT level 2 certified in ultrasound testing, magnetic particle testing, and dye penetrant testing. So that's about me. Here is the most famous quote from Afra Ben. Some of you might already know this. Money speaks sense in a language all the nations understand. Do you speak money? Well, you should. It is the world's most important language. So, why the money language is important? By this time, we all might have the opportunity to save our organization a great deal of money at different times with different opportunities, which would have resulted in a significant cost avoidance. And most of the time, our work will result in improved uptime and improved product quality, which would ultimately improve the profitability of the organization. But here comes the question: how good you are at letting know them to the management. So the condition monitoring involves a lot of advanced level trainings. If at all you want to go for a training, how would you convince your management for the training? Is it easy for you, or you are getting yourself trouble for this? Unfortunately, not everyone in the organization understands the condition monitoring language. In a typical condition monitoring program, we have different techniques to follow. As we all might know already the techniques. So here are some of them, namely the vibration analysis, balancing and alignment. These are all the precision tasks, though they are more of a proactive approach. Most of the time it comes under the condition monitoring cell's responsibility. And we have oil analysis, which includes used oil analysis, including ferrography, via debris analysis, and so on. And we have infrared thermography for electrical, mechanical, and process applications. And we have ultrasound inspection for bearing monitoring and ultrasound aided lubrication. And we have electrical motor testing, including the electrical motor diagnosis and motor current signature analysis. And apart from these traditional techniques, we have some sort of critical measurements which are very crucial for the plant equipments. And other than that, we have some kind of non-restrictive testing, namely the ultrasound testing, magnetic particle testing, and visual inspection, etc. So it is often a question that what are the things that need to be considered while making any successful business case or while submitting a proposal for a new tool or an instrument or a proposal to your new upcoming training. So let's see them one by one. So for any industrial engineer, safety is the first priority. So safety involves safety of a man, safety of the equipment, or safety of the environment. For example, a loose coupling or excessive misaligned coupling could be a danger to a man who is working nearby, and a high temperature terminal could be a danger to the motor, which may cause a flashover. A failure of a dust collecting fan could be danger to the environment, which would cause a poisonous or dusty gas to go into the environment. So safety makes more sense in an industrial environment. So you can highlight all those safety points in your proposal or in your case study. Another obvious thing to consider is the cost involved in loss of production, which can be easily calculated by hours of downtime multiplied by production tonnage multiplied by per ton cost. Sometimes, due to the abnormal condition of the machine, we are forced to run the equipment with reduced production, which is also a production loss, or sometimes we are compromising with the quality. So we can consider these things and we can calculate the numbers accordingly. The next point is the energy loss involved. The energy loss may be your electrical energy loss or a thermal energy loss or a mechanical energy loss. So energy loss involved in an equipment which is running abnormally is a common phenomenon. Let's say an equipment running with severe misalignment takes 1 to 3% extra energy than a normal equipment. Similarly, it is the same case with equipments running with high unbalance and high vibration, maybe a faulty cable identified in thermography, a high temperature spot identified in a boiler or a process cyclones. They all contribute to a different sort of energy loss. So you can calculate the money involved in the energy loss and you can project it right away. The next point to consider is secondary damages of other components. So let's say a defective gear in a gearbox can damage its mating gear, and a faulty bearing in a gearbox could result in improper loading on the gear or misalignment, which could cause the damage of the gear. Similarly, a faulty bearing could damage the shaft, seals, etc. An excessive imbalance could damage your bearings, which in turn could damage your housing or shafts, and so on. An excessive misalignment could damage your coupling, bearing, and seals. So you can consider all these secondary damages and you can calculate this cost involved in this spare parts. The next point to consider is the manpower cost involved in breakdown. In an uncertain situations of breakdown, arranging a manpower would be a difficult task since it is an unplanned activity. We may not be getting the additional manpower, so we are forced to pay the overtime. And again, the skillful workman and the resources are also a questionable things. So if you are avoiding a breakdown, you're saving the manpower cost and you're avoiding the overtime cost. You can consider these things while making your case study or a proposal. The next point to consider is your plant startup cost. So if an equipment failure is avoided, you're actually avoiding the startup cost in a typical manufacturing industry. So let's take an example of a cement plant or a power plant with boiler. So if a breakdown of an equipment leads to stoppage of main equipments like your boiler or your kiln, uh, it gets cooled down and you need to start the plant again, which requires uh, more fuels in terms of whether it may be a coal or it may be a diesel, or even you may consume the power of an auxiliary equipment. So while projecting your savings, you can consider all these factors and you can calculate the money involved in the same and you can project it accordingly. The next point to consider is a stoppage power cost due to breakdown. So in typical manufacturing plants, let's take an example of a cement plant. If your main equipment stops, let's say if the kiln stops, it will not able to produce the clinker, so that then next the next immediate equipments like crushing mills or packing plant, everything has to stop. So in this act causes the auxiliary power consumption to go high. Even you can record those powers and you can project it in the monetary form. The next point to consider is the inventory. So inventory in simple terms, it's the money trapped in stores doing no work. The more inventory you have on your hand, the greater the amount of business capital is tied up. You will risk slowing down your business cash flow. So if you have a good condition monitoring program in place, we need not to keep the costly inventories like your costly bearings, costly gears and all in your store, which will help the business. You can calculate the inventory levels before and after implementing the condition monitoring program, and you can project it right away. So another point to consider is your costing involved in avoiding a support from third parties. So if you're performing some kind of condition monitoring activities which was previously done by some other third parties, which was an costly effort, by doing a cost benefit analysis, you can project the numbers to your management, and by doing proactive actions like precision alignment and precision balancing, we are avoiding the basic problems at the first place. Thereby, we are saving a lot of money and time. So here is the summary of points to be considered in terms of money. So the first one is your safety and cost involved in production loss, energy loss involved, and secondary damages of the other components, manpower cost involved in breakdown, plant startup cost, stoppage power cost due to breakdown, the inventory cost, and cost involved in support from the third parties. And there are some points that need to be considered while projecting your savings. The first one would be you should not exaggerate your numbers. You should calculate or estimate the money according to your facility setup and the practices that are being followed. So your number should be a realistic one. And the other point to consider is you need not be too conservative either in projecting your numbers. So you should have a logical number with the proper calculation. So the one way is to discuss with the respective people to get the calculation right. Another important point to consider is your sustainability. You should keep updating your case studies and keep sending periodic reports of your savings along with your normal routine reports so that you can keep your momentum going. I'm going to share some case studies with you now. The first case is about vibration analysis. So, a vibration report was issued on a Colmel drivetrain arrangement asking for a drivetrain alignment check and the girth gear and pinion contact. So this particular coal mill has the following drivetrain arrangement. It has a motor, gearbox, torsion shaft, and pinion and girth gear. So based on the above report recommendation, the gearbox and drivetrain alignment was checked and it was found out of the limit. You could see the alignment readings were abnormally high, 7.35 and 4.42. So the site has decided to correct the alignment and they found there is no room for gearbox lowering the gearbox. So they decided to replace the base frame. So after the alignment and replacing the base frame and correcting the alignment, the vibration levels were reduced from 7.3 mm per second to 4 mm per second. So this was a classic report we normally submit to our customers or our production department or and so on. So this doesn't revealing anything important for a common person. So the typical reaction will be like, oh, something is reduced, it's a good job. And here is another way of submitting the same case to our customer. So the same case was submitted with the savings achieved. So in this particular case, the startup cost savings from the startup cost was $5,500, which means if this main coal mill stops, it stops the main equipment, which would have resulted in restartup So the startup cost is a direct saving unless it is a planned outage. So this is the additional cost spent on the startup. So and another thing to consider is the stoppage power. So breakdown of this particular piece of equipment would have resulted in consumption of some auxiliary equipments from the production line. So that was estimated and it was $660. And inventory cost, since this problem has been identified early, and the manpower planning and material planning has been done properly. So we avoided the inventory cost, which involves maintaining the inventory and the manpower involved in maintaining the same. So another another parameter is the secondary damage. If this huge misalignment would existed, it would have caused the damage to the torsion shaft in supporting bearings and even the pinion. So the savings from considering those factors, so the savings from the secondary damage is $6,400. And the manpower, this is if we don't plan the manpower planning for the job, it would result in overtime, which is an excessive money. That was around $980. And of course, the production loss, it was a 15 TPH mill. It, it was stopped for the breakdown would have resulted 48 hours, so totally 720 tons of coal. So this, if we convert this into money, this would have been in crores of rupees. So in this particular case, there is a silo storage system. So I haven't considered the money, but I projected the production tonnage. So the summary here is, from this particular failure, we saved around $13,740 and we have avoided the production loss of 720 tons. So this was the reaction. Oh, great. This is a great job. The next example is of infrared thermography application. So this was a case of process thermography in a cement plant cyclone system. The thermography has been carried out, and it was found that there was a red spot here at the cyclone, and this was due to a failure of the refractory inside the cyclone. So after the corrective action, the temperature around this area has been reduced from 267 degrees to 80 degrees. So what happened here is we actually avoided the radiation loss around 180 degrees. So that would result in savings of around 3 lakhs Indian rupees. So the calculation below is the calculation used to calculate this savings. This was particular area, and average temperature around the area. So we can directly calculate the heat loss by calculating the various factors of fuel use and all. So it's worth doing it. And this is another case of thermography. We could see there are two hydraulic cylinders. The one at the left is a normal cylinder with normal operating conditions. So the one at the right is the defective one, where we could see a high temperature zone in this particular area, and this is due to the in friction around the cylinder valve and the loss of material, which would cause the internal leakage inside the cylinder. This would ultimately result in stopping the mill. because this hydraulic system cannot able to perform its intended function, which would cause the downtime. So in this particular case, the same was identified, and it was estimated that the savings of 5 lakhs has been done in this particular case. So this is another qualitative thermography example from an ID fan. So it was found that one of the bearing in the fan was found abnormally high in temperature when compared with the other bearing. So it was recommended to inspect the bearing. Upon inspection, it was found that the grease was decolored into black, and the root cause for that was the outer ray started rotating inside the housing. So, if this was not identified timely, this would have caused failure of this bearing. It ultimately would have resulted in the stoppage of main equipment. So, by the way, we are saving that from savings from this particular occurrence is around 4 lakh Indian rupees. So this is an example of savings achieved through a laser alignment. So we did a study in our facility for a small air slide fan. So the fan which was having misalignment was measured. It was taking 12.2 amps with the misalignment. After being realigned, this came down to 11.8 amps, which is a 3.28% reduction in the power, which equates a 0.288 kilowatt saving in 7,500 Indian rupees over the course of 1 year. So it can be assumed that the power consumption of all machinery will reduce by 1% at least. This is likely to be an absolute minimum, but though we there are a lot of studies which are being done, and the results were up to 5% reduction in the power. So you can actually list out what are all the drives, different kinds of drives with power in your facility, and you can quantify them in order to find the potential of savings. With that saying of proper alignment could save your power uh, at least minimum 1%, you have to your alignment report should have these kind of informations along with savings achieved through it. In this particular case, a, a VRM3 mil fan was aligned, which was having taking the minimum power of 2.2066 kilowatt and maximum power of 2237. So taking the minimum kilowatt also, it comes around 20, taking 1% calculation, it comes around 20.66 kilowatt per hour. For a total year, it would be around 1,48,752 kilowatt. So considering your per unit power cost and running hours and average running days, you can easily calculate the amount of saving. In this particular case, it was around 5 lakh Indian rupees. Your alignment report should have these kind of explanations to increase the weightage of your report. Here is another interesting slide about doing a perfect balancing in rotating equipment. So there was a study where it was observed that the average power loss due to unbalance is of 0.11 watt per gram unbalance, which means if you have an unbalance of 50 grams of your rotor which is having 500 radius, you could it would cost 2.75 kilowatt power excess. So here in this particular case, there was an heavy imbalance in process fan, so wherein we have added weights of total 3 kgs at two different locations. So after balancing, the vibrations levels reduced from 8.7 mm per second to 3 mm per second. So in this case, there are huge imbalance components, and the residual imbalance before and after balancing can be calculated easily. If you're using a vibration analyzer for balancing or some other means, you know what is the residual imbalance before and after balancing. From that, you can do the power calculations as per the study. And in the other hand, we know that this excessive imbalance would result in the high vibration, which could damage all other components. Again, the information I provided in the first slide applies here. Here is an example for oil analysis program. So on a schedule analysis, it was found that the gear oil chromium content was high, so it was recommended to replace the oil. This particular piece of gearbox is under scheduled monitoring of oil condition since long time. The normal recommended running hours for this gear oil is 14,000 hours, but by continuously monitoring the oil condition, the running hours has been extended to 2.3 times higher. So the saving achieved here is we now actually avoided the 2 times oil replacement, which includes this is a 8,000 liter sump capacity gearbox, so total 16,000 liters of oil, and the manpower involved in replacing the oil is actually saved. You can also consider the inventory cost for the 2 times replacement. So in this particular case, the cost saving calculated was approximately 6 lakhs Indian rupees. This is an example of ultrasound testing. So as a part of acceptance testing, we have a practice of doing ultrasound, dye penetrant and magnetic particle inspection on the new spare parts. So one of such inspection, it was found that a rock breaker cylinder head was having a crack up to 5.6 mm. Since this was a new spare received from the supplier, so this we identified this crack and we sent it back to the supplier, which otherwise would have resulted in the cylinder internal leakage or breakdown of the cylinder, which would have resulted in the downtime. So in this particular case, considering the downtime of the equipment and the additional damages, the estimated saving was around 10 lakh Indian rupees. This is an example of critical measurement. The critical measurements include taking the wear measurement or hardness measurement or wear rate in different equipment parts of the critical assets inside the plant. So one such case was the belt elevator carrying a raw material to the silo. So in this particular case, the belt and the bucket was separated by a rubber strip, which actually takes the major loads and it is protecting the belt. So by keep on monitoring the belt and this rubber strip condition, we could actually increase the life of the belt and we can plan the replacement at the right time. Since these belts are very costly spares to keep in the inventory, there are ranging from approximately 25 lakhs to 60 lakhs depending upon the size. So by monitoring this belt closely, we are avoiding such costly inventories in keeping the costly inventories in our stores. So in this particular case, we have enhanced the life of the belt to some extent. So from this particular case, we have saved around 5 lakhs Indian rupees, and we also avoided the high value inventory. The next thing we are going to talk about is the ultrasound inspection. So if you already have an ultrasound inspection in your plant, or you are about to go for an ultrasound inspection methodology, you want to propose something to your management to get approval, you can use the following things to get the approval. The one first thing is the ultrasound aided lubrication, wherein we could find a lot of savings in the grease consumption. And the next one is the compressed air audit. So in a typical manufacturing or a process industry, the usage of compressed air is a energy intensive thing. So you can use this ultrasound technology to identify the compressed air leakage. You can do an audit and you can project the saving potential. So another thing to consider is the early bearing failure identification. This is a very good tool to identify the bearing failures in the early stage. You can, if you have a program already and you are using it for a bearing monitoring, you can compare it the bearing consumption before and after the program. So similar way we can use it for a lot of electrical applications, including the corona identification, arcing, tracking in transformers and other electrical appliances. So once you are succeeding in recording all your success stories, the next thing to do is talking in terms of KPIs, some key performance indicators. Most of the plants already be tracking all these parameters. So we can also start reporting the numbers before and after implementation of the condition monitoring program. We can calculate the overall equipment efficiency before and after the program. In the similar way, we can compare the availability of the each and every equipments which are under our condition monitoring program. Similar way, we can also calculate the mean time between failures for each main equipment and the spares inventory, where if our program is successfully running, we could expect some reduction in the spare inventory. In a similar way, our overtime labor cost should go down and our annual maintenance cost should also go down. If we talk in terms of these KPIs, this this will increase the weightage of the condition monitoring program. And here is the summary of this presentation. So you need to record all your success cases, whether it may be a smaller one or a bigger one. So this is a really important point. Oftentimes we are lagging in this particular area. So irrespective of the significance, you need to record all your success cases. And from the whole presentation, this is what we are trying to say. Your report should have a common language as we understand it is going to the all different peoples, both technical and non-technical people. So our report should have a common language, which is a language of money. Then comes the proactive submission of your periodic reports with savings achieved to all your stakeholders. This is in order to make the people understand the significance of a program, that it may be a condition monitoring program or a reliability program. To make the people understand, you need to do these sort of things. The next one is, before proposing for any new instrument or new tool or maybe a next level of training, you should submit a successful business case by considering whatever the point we have discussed so far in the presentation. And you need to, once your program is successfully implemented, you need to show the improvements of the program before and after implementation. And the last but not the least, you have to make sure that the right people in your organization know. So all these things are driven by a leadership people in the top level. So the right people should guide us for the right things. And thank you very much for listening to this video. For more videos related to condition monitoring and reliability, please subscribe to the below YouTube channel. Thank you very much.